Welcome once more to Inno tutorial. This lesson is going to be an introduction to stress and strain. So you are going to understand what we mean by stress and what we mean by strain in this lesson. So understanding stress and strain in mechanics of materials or mechanics of deformable bodies is really important. You need to understand what we mean by stress and what we mean by strain. Now, to properly understand stress and strain, we will take a look at three different scenarios. So these scenarios will help us understand stress and strain. So let's take a look at the first scenario. Now, as you can see, we have scenario 1 on the screen. So as you can see, we are having two rods. We're having two rods. This is the first rod and this is the second rod. So this rod, they are made of the same material. So let's say this rod are made of the same material, and let's say this material is aluminium. So they are made of aluminium. Now the question is, if we apply the same force of 200 kilonewton on this rod, which one of these do you think is going to fail first, and why do you think it is going to fail first? Now the answer to that question is the first rod is going to fail first, because we're having a smaller area on the first rod than the second rod. So this is going to fail first. So like I said, the first rod will fail first because of the section geometry. So section geometry, this is really important. So you really need to understand section geometry. So now, like I said, it is not the force that is significant, it is a stress. So it is not the force that is really significant, it is the stress, because we know that stress is equal to force over area. So if we have the same force applied on two members, this, depending on the section geometry of those members can have a different stress. And the reason they're having a different stress is because of the section geometry, that is because of the area, because of the difference in area of the two members. So because we're having a different area, it is going to result in a different stress. So if we are having a larger area, it is going to result to less stress, but if we are having a smaller area, it's going to result to higher stress. So make sure you take note of that. So for the scenario 1, if the lower rod was, let's say, 3 times larger, it will take a force of 600 kilonewton to fail the lower rod. That is, if the lower rod was 3 times larger, that is, the area of the rod is 3 times larger, it will take this 3 times the force that is required to fail the first rod. It will take this 600 kilonewton to fail the rod, because we are having a larger area. So this is going to result to less stress. So you need to know that higher area is going to result to less stress, while lower area is going to result to higher stress. So let's take a look at the next one. So now we are having scenario 2. Now for scenario 2, we are also having two rods. We are having two members. Now these two members, they are made of different material. We are having the same force applied on both members. Now let's say the first rod is made of alloy and the second rod is made of, let's say, plastic, and we are applying a force of 200 kilonewton on both of these members. Now the question is, which one do you think is going to fail first? That is, if we apply a force of 200 kilonewton on the alloy member and a force of 200 kilonewton on the plastic member. Now, of course, the plastic member is going to fail first because of the difference in material. Okay, so the plastic member is going to fail first because alloy, they are much more stronger than plastic. So the plastic is going to fail first, and this is because of the difference in materials. So that is the answer to the question. The plastic member is going to fail first before the alloy member, because alloy, they are much more stronger than plastic. So the plastic is going to fail first. So this is scenario 2. So like I said, material properties affect how sections respond to applied load. So if we have different material properties, this really affects how the session will respond to applied load. For example, wooden materials, we tend to split. That is, if we applied a load on wooden material, they may tend to split. But let's say if we have cementitious materials, that is concrete, they don't concrete don't split. Concrete they may tend to crack. So as you can see, due to the difference in material, the session is going to respond. Okay, so it's going to respond to the applied load due to the difference in material. So wooden material, they may tend to split. Cementitious material, they may tend to crack. And alloy material, they may tend to bend. So this is scenario 2. So now let's take a look at the last scenario. Now we have scenario 3. Now on scenario 3, we are having the same material. We are having the same material and we are having the same area. That is, we are having the same section geometry. But now the difference is the way we apply the load on this material. This is the only difference. Now, if you take a look at the first member, this member we are yanking on this member. That is, we are applying an axial force on this member. And on the second member, we are applying a torsion. As you can see, we are twisting this member. As you can see, the way we load these members are different. Now the question is, will the two rods behave the same? That is the question. Will the first rod and the second rod behave the same? Of course, they will behave differently, because the first rod, we are applying an axial load on the rod. That is, we are yanking on it. So we are trying to make this rod fail axially. But on the second member, we are applying a twist, that we are applying torsion on this member. So they will respond differently because of the way we apply the load on the member. So they will respond differently. Now let's say, for example, let's say you take a paper clip. For example, if you take a paper clip, if you apply torsion on this paper clip can easily deform because we are twisting on the paper, right? So it can easily deform. But if we apply an axial load on this paper, it's going to be very, very difficult to deform this because the paper clip, they have a greater they have an higher resistance as into axial load, but they have a lower resistance to torsion and twisting. So due to the way we apply the load on the members, they will respond differently and they will deform differently. So this is scenario 3. So now if you take a look at the screen, we have different stress for different loading. Now the first one we have is axial loading. So the axial stress is the force over the area. The second one is the bending. So this is the bending stress. Then the third one is the shear stress. So this is the formula for the shear stress. And the fourth one is the torsion stress. So this is also the formula for the torsion stress. So we are going to be using this to analyze and design a member. So stress is basically the applied force divided by the area, and the strain is basically the change in the length of the member due to the stress. So if a member is experiencing higher stress, this member is going to have a higher strain, okay, because the member is stressed, so it's going to have higher strain. So but if a member is receiving lower stress, the strain is going to be less. So strain is basically the change in the length, that is the change in the length divided by the original length. So this is what we know as strain, and stress is basically the force divided by the area. And we have different types of stress. We have axial stress, we have bending stress, we have shear stress, and we have torsion stress. So this is what we know as stress and strain, and I hope you understood everything I said so far. And if you don't understand any part, just ask me the question in the comment section below, and I'll see you in the comment section to answer all your questions. And please don't forget to subscribe to the channel and click the like button. Also share the video with your friend, and I will see you all in the next lesson. Bye.